Good morning, or in better yet, we can say bom dia, Pavo de Angola. I hope I said that right. Okay, so my name is Rose Delilah Gesicho. I'm currently based in Kenya, Nairobi, and I am really excited to be part of this launch brought to you by Yango in collaboration with Zindi. So I am the community coordinator at Zindi, and what I do is I work with different ambassadors across Africa who are very dedicated and enthusiastic to ensure that we have data science across Africa, and that means also in Angola, where we are currently collaborating with Yango. And I also work with different communities, and that is a thing that I'm very passionate about, and I'm happy to also be in this launch to enable you guys to get started with your data science hackathon, and I hope you're excited about it. And another thing is that I am excited to see that this Saturday morning, you guys are logged in and excited to be in this hackathon and to put your hands get your hands dirty in working on this challenge and getting a solution for it. And it's gonna be beneficial to not only Yango but also the society at Angola. So I am excited for you, and I hope you're also excited. And without further ado, I hope you guys are joined in on the YouTube chat where you can be able to tell us where you're joining from, what's your name, what do you currently do, and where you're joining from in Angola. And better yet, please tell us how the weather is there, because currently in Nairobi, it's a bit cold and just a bipolar weather. So we're really trying our best to keep warm here. So just tell us how the weather is currently in Angola. So before we get started with this hackathon, where I'm going to bring in Amy, who's our competitions lead, who will take you through the tutorial, and the amazing team at Yango, I wanted to just share with you guys my back-end story as a data scientist before just the hackathon gets started, and also just share with you some tips and tricks on the back end for you to be able to get started as a beginner. So I have a background in data science. And also have worked as a mentor in different organizations as a data scientist, where I have been able to mentor over 100 plus people getting started into data science. And I know how nerve-wracking it can be when you're starting off a hackathon and maybe you have limited knowledge about data science, because yes, data science has just been launched as a unique part of the technological system. And I know that it might be a bit nerve-wracking. We have said this for the last 3 years, but then people are still getting started with data science, and it can be nerve-wracking doing a hackathon. And one thing I can congratulate you on is just being able to join in this hackathon and challenge yourself. That's amazing, and that will put you on a higher note when you're getting started. And another thing about it is that you are able to now collaborate with other people. That is one thing that I can ask you to do. Just collaborate, because then you're going to be able to learn from others, and also learn just how you can be able to solve different challenges in different ways. That's another trick that I can send you on. And maybe the last thing that I can share is just be confident in yourself and do research. We have ChatGPT, which is, the it thing right now. And I bet you guys, when you have a challenge or a blocker, feel free to research there, and you're going to get better solutions and how you're going to also improve your models. So without further ado, I'm going to bring in our competitions lead, who's going to launch the challenge and also bring in the Yango team to discuss more. So Amy, are you around?
Hi, Delilah. Thank you so much.
Hi. Thank you.
What a privilege to be there. And I heard Delilah greeting you in Portuguese, and I'm sorry I'm not as brilliant as her. I don't know any Portuguese. And I think good night is benoit. I don't know what hello is.
Isn't that
Great. So good to have you here. I'm going to share some slides. I can see that some people have already made comments in the YouTube comments, so please continue to add comments. I was watching you and Golan's sign up to Zindi yesterday, and it just made my heart so happy because there were so many of you signing up for the first time, which means Zindi might be a bit scary to you, and that's okay. Zindi was my first job, is my first job. I've now been at Zindi for 5 years. So I just want to let you know that it's okay to be a bit scared and a bit intimidated about Zindi. But we are going to learn together, and I'm going to be here the whole day. I'm going to be at my computer, so if you've got any questions, put them in the discussion board, and specifically during this hour, add them to the Zoom chat, not Zoom chat, YouTube chat. How this agenda is going to go, we've had a welcome from me and we've had a welcome from Delilah. Soon I'm going to hand over to Ivan from Angola, who's going to tell us a bit more about Yango, as this hackathon and event is powered by Yango, which we're so grateful for. I'm going to introduce you to Zindi, and then I'm going to introduce you to the challenge and the data. I'm then going to walk you through a notebook, and then we can have a bit of a Q&A session. Quisa, I'm sorry, I don't know how to pronounce your name. You are correct. You can't see the data set on Zindi just yet. You are going to need to wait another 55 minutes, and then you'll be able to see the data set. So don't worry. I will show you how to run a notebook, how to start a notebook, how to make a submission to Zindi. What is Zindi? The hackathon will then start. When the hackathon starts, you'll be able to do 3 things. 1, download the data. 2, download a starter notebook or starter code. And 3, make a submission. The hackathon closes at 6 p.m. So please make sure that your submissions are in before 6 p.m. and then join us back at 6:15 because we'll be announcing the winners then, which is my favorite part. Ivan, I'm going to be handing over to you to hear a bit more about Yango in Angola. Sorry, Ivan, you're on mute. Do you mind unmuting yourself, please?
Okay.
There we go. Now we can hear you. Perfect.
Great. Different from Amy, I can speak Português. Bom dia a todos. Eu sou Ivan Mugimo, sou o diretor-geral aqui da Yango em Angola. E epa, é um enorme prazer e satisfação para nós aqui da Yango, em colaboração com a Zindi. Podemos ter essa oportunidade de apoiar um projeto tão bom como esse hackathon sobre mobilidade urbana, não é? Utilizando dados reais da nossa realidade aqui, da nossa grande cidade de Luanda. Como muitos de vocês já sabem, a Yango é uma empresa tecnológica e nós usamos a tecnologia para prestar serviços. Nós usamos a tecnologia para resolver problemas do dia a dia da nossa realidade. E a Yango é uma solução criada para resolver o problema da mobilidade. Como sabem, mobilidade é um grande desafio para a nossa cidade aqui de Luanda. E a Yango veio exatamente utilizar a tecnologia, o melhor que a tecnologia tem para oferecer, para dinamizar então aqui a mobilidade da cidade de Luanda. E como é de conhecimento, a mobilidade continua sendo um desafio na nossa cidade. E a Yango está aqui comprometida então para ajudar a facilitar a movimentação de pessoas, né? Poder tirar pessoas do ponto A para o ponto B. E esse desafio, esse hackathon é mesmo, vem também para ajudar isso, dar uma oportunidade para vocês, a nova geração de data scientists, cientistas de dados, prontos. E vocês podem então aqui usar aquilo que vocês já aprenderam, o conhecimento que vocês têm para ajudar então a prever a mobilidade do tráfego em Luanda. Só para contar aqui um pouco da minha história. Sabem que a Yango está aqui em Angola há cerca de 1 ano e meio. Mas a minha paixão pela mobilidade começou muito antes, enquanto era estudante na África do Sul. Como estudante, eu apanhava muito autocarro. Eu estava sempre a apanhar os autocarros públicos, mas eu estava sempre ou atrasado ou a apanhar o autocarro errado. Entrava no autocarro e ia parar na outra parte da cidade de Joanesburgo, longe da minha universidade, porque não tinha tecnologia para ajudar. E eu pensei, e no final do ano nós tínhamos que apresentar um projeto. E pronto, foi sugerido, implementa um projeto que resolva um problema do dia a dia. E eu pensei, a minha maior dificuldade é mobilidade. Por que vamos usar a tecnologia para melhorar a mobilidade na cidade de Joanesburgo, implementando tecnologia nos autocarros? Então, o projeto era instalar GPS nos autocarros, para que as pessoas podiam ter informação através de um aplicativo, ver a movimentação dos autocarros, saber onde os autocarros vão, o ponto de partida e vários pontos onde os autocarros iam passar. Isso ia permitir que as pessoas não perdessem o autocarro, ia permitir que pessoas como eu deixassem de entrar no autocarro errado e parar em outras partes da cidade. Então, a minha paixão começou aí. E pronto, quando recebi essa oportunidade para dirigir um projeto como esse em Angola, uau, não pensei duas vezes, larguei tudo para dar cabeça a esse projeto. E felizmente o projeto tem dado muito certo aqui em Luanda. Então, essa é a minha história. Então, contamos com vocês, contamos com a vossa criatividade e esperamos que isso possa ser um hackathon maravilhoso. Vamos estar aqui desse lado a acompanhar então aqui o vosso trajeto. Muito obrigado mesmo e boa sorte a todos. Até já. Bye.
Thank you so much, Ivan. I hope everyone else understood, because I didn't understand anything. And I think it's incredible that you can speak both languages. So thank you so much.
Thank you, Amy. It's a pleasure.
I'm going to continue with our slideshow. Please remember to share any pictures with us on X or Twitter. You can share it at Zindi Africa. Please remember to tag Yango Education and hashtag Zindi Hack. We'd love to see what you're doing. Normally hackathons are quite quiet because your brain's just on fire and you're just sitting there hacking, but send us a picture of all your snacks or your concentrating face. That would be great to see. So the competition information, this is an incredible data set powered by Yango. It's got real live data from Luanda, and it's the Luanda Mobility Prediction Hackathon. It starts in 45 minutes at 10 a.m. and it runs until 6 p.m. tonight. And the objective of this competition is to create a machine learning model or an AI model to predict the average speed of traffic at 6 a.m. and 6 p.m. I know many of you signed up to Zindi yesterday. If machine learning prediction sounds scary, don't worry. Delilah mentioned that ChatGPT is your best friend, and I'm going to say it again. You can work alone or you can work in a team of up to 4 people. I highly recommend working in a team, as then you can ask questions, rely on each other, get encouragement, and all those other good things. You can only participate in this competition if you are from Angola, so please ensure that your profile is set to Angola on Zindi, and I'll show you how to do that. Prizes! I think that's the main reason why many people are here. There are $1,000 up for prizes today, powered by Yango. Thank you so much, Yango. So there's $500 for the first place team or individual, $300 for second place, and $200 for third place. You have to be an Angolan citizen or resident, and you will need to share proof if you are a winner before we release payment. Competition rules, as mentioned, you can participate individually or in a team of up to 4. If you are in a team, we encourage you to share information inside your team, ask for help, share motivation, but it is against the rules to share information outside your team. Please don't share it with individuals or other teams who are not in your team. If you would like to share information or insights or encouragement, we encourage you to share it on the discussion forum, and I'll show you how to do that. Please only use the datasets provided on Zindi. I'll show you where to find those datasets. They'll be available in 44 minutes now. If you are in first, second, and third place, please look out for an email at 7 p.m. tonight. An email will come from Zindi requesting that you submit your code and your solution. This is very important. The data science team, which includes myself, will be running your code and ensuring that it makes sense and that it provides the solution it says it does. If you are an advanced data scientist, please pay attention to this. You can only use publicly available and open source packages. If that statement did not make sense to you, don't worry. It's specifically targeted at advanced users, and it's very rare that we see this anyway. Again, this is only for Angolan participants, although I want to let you in on a little secret. At the same time, while you are working in Angola, we have a whole nother country, Mozambique, working on a similar competition in Mozambique. They've got their own Mozambique dataset, and you've got your own Luanda dataset. But we would, and you can go and sneak on them and see what their Maputo score is. Just remember the data is specific to Mozambique and your data is specific to Angola. But there's going to be a bit of country rivalry, which is always a good thing. It just allows you to share your country pride. Okay, the structure of the data. Just to let everyone know that I can see your comments coming through on YouTube. And I will answer them as we go through, so please don't be shy asking questions. Yango has provided data for Luanda, and they've cut up the roads in Luanda into road segments, and these road segments are referred to as persistent IDs. There are about 3,000 persistent IDs, or 3,435 road segments. There are also 7 days of the week. The names are named a bit weirdly, but this information is on Zindi and will be available in now 42 minutes. It's quite fun having this countdown. So first weekday refers to Monday, second weekday refers to Tuesday, and then other holiday refers to Sunday. Excuse me, I just need to sneeze. We then have 2 prediction types. So we are predicting the whole rush hour for 6 a.m. in Maputo for specific persistent IDs or specific road segments. And we're also going to predict the whole rush hour for 6 p.m. at specific road segments. So now you can see we've got a lot of information. We now somehow need to identify a persistent ID or a road segment, the day, and the time. And so this is where we get our unique identification for each of these road segments, day and week. So with our 3,000 persistent IDs, our 7 days, and our 2 prediction types, we have 46,000 rows of data, which is crazy. And the way we identify each of these 46,000 rows of data is by this standard form of saying the persistent ID cross what day of the week is it? Is it first holiday? Is it second weekday? And then what type of prediction is it? Is it the morning rush hour or the evening rush hour? These 46,000 rows of data we have split into two sets. We split them up into train and test. And what's specific about this is that none of the train and test overlap. So for example, I don't know how to pronounce this, so I hope everyone can have a good laugh. So for example, the road Rua da Bovista is in train and only in train. And then the road Ponta do 25 is only in test. So there's no way of those two crossing each other, which makes quite an interesting data problem, because does this side of the city's traffic, is it similar to this side, or is it different because maybe it's near the harbor or near the schools, or and that's something that you as a data scientist living in an area, it's called domain knowledge, will know. Okay, so now we've talked geography, but we're missing a key component. We're missing time. It took me a long time to try and wrap my brain around it. And so I understand if this is going to be a bit scary or a bit intimidating for you. I want to reassure you this video will be online, so you can come back to it. We have data for the full 24 hours in every single day. And instead of giving you the data every minute or every second, we've decided to give it to you in every quarter. So if we're looking at that first row, you will see that there's instances of 000, 001, 002. That means midnight, 00, the first quarter, 0. So that's midnight to quarter past midnight. 001 is the second quarter of midnight. So that's quarter past midnight to half past midnight. Let's look on the very end of that column, row, to the last column where we've got 013. So that's the fourth quarter of 1 a.m. So that's quarter to 2 to 2 a.m. So that's how the data is split up every 15 minutes. We then have count norm. So count norm is the normalized number of car trips. I find it quite difficult to think about it as normalized. So the way I visualize it and the way I speak about it is at midnight in the first quarter, so from midnight to quarter past midnight, 0.81 cars traveled along that segment. And from midnight second quarter, so from quarter past midnight to half past midnight, 0.034 cars passed in that segment. I'm not going to go all the way to the end of that row, last column. In the third segment of 1 a.m., so 1:30 to 1:45 a.m., 0.36 cars traveled along that specific segment. All well and good that we've got cars that travel along long segments, but how fast were they traveling? So for this specific persistent ID, which is this specific road segment, at midnight in the first quarter, so from midnight to quarter past midnight, those 0.81 cars were traveling at an average speed of 16.7 meters per second, which is quite fast. If we go all the way to the end of that row, that last column, the average speed at 012, So the third quarter. So that's, I hope you can see what I'm doing over here, because I'm also, it still gets me confused. I'm going up, so I'm looking at that bottom thing. So the average speed look at the timetable. So that's from 1:30 a.m. to 1:45 a.m. 0.36 cars were traveling at an average speed of 20.98 meters per second. And that's our times. Whew. Let's see what this side. So now, if your brain isn't broken yet, I'm going to break it a bit further, but I want to just to keep encouraging you that I started off not knowing anything, and now I'm a full-blown data scientist, which means you can reach my level too. As I mentioned, we have data for 24 hours every single day, every 15 minutes. But for the evening and morning rush hours, 6 a.m. and 6 p.m., you are not predicting every 15 minutes. You're predicting the whole hour. So you're not going from 6 a.m. to 6:15, 6:15 to 6:30. No, 6 a.m. to 7 a.m., what was the average speed? One data point, not 4. And then we've given you, for the morning rush hour, we've given you data from midnight all the way up until 5:30. We have not given you data from 5:30 to 6 a.m. That data is missing, just to be a bit sneaky. And so that data you are going to build a model that takes in data from midnight to 5:30 in 15-minute increments to predict the 6 a.m. hour. And similarly, for the 6 p.m. hour, you have data from 7:30 in the morning all the way up until 5:30 p.m. And you will use that data to predict from the whole hour of 6 p.m. to 7 p.m. I'm sure your brain is breaking, but that's okay. I'm soon going to go walk through. I start a notebook, and I'm going to walk through the platform to show you what's going on. Just if you have any questions, please continue to put them in the private or in the YouTube chat. Ask on the discussion forums. You can't get help if you don't ask, so ask those questions. And please remember to ask us on Twitter and on X. You can tag us at Zindi.Africa, #Yango Education, #ZindiAfrica. We can't wait to see what you're doing. Please, can you give me a minute while I share my screen so you can see what's going on? Brilliant. You can now see Zindi. If you go on to Zindi.Africa, you will, in the top right-hand corner, there is a button called Sign Up or Sign In. I already have an account, so I'm logged in. Now I'm going to go and click Edit My Profile. I'm going to change my country from South Africa, and I'm going to pretend that I'm from Angola. Why? Because I can. If you would like, you can go to your career section. You can update your education, your work, your data science strengths. You can also upload your CV. This is amazing because we have a talent portal where we link data scientists such as you to organizations around the world. So make sure that your profile is up to date. Back to my profile, country still Angola, awesome. Here is the little flag. It says University of Lusaka next to my name, which is incorrect. I'm going to change it to Rhodes University, which is the university I went to. I should probably change it to Zindi because that's where I currently work. I'm then going to click on compete. I'm then going to go to hackathons, and you'll find the Luanda hackathon, and it starts in exactly 30 minutes, which is quite exciting. And we've got 94 users enrolled. On this first page, you can find out more about Zindi more about Yango in their video. You can learn more about the competition and what's expected from you. More about Yango. Here is the live stream, so you can come back and watch this, and it will be a bit of like an inception. And you can find out more or rewind to learn about anything you've missed. At 6:15 tonight, please can you join the second stream? This is where you'll find out who the winners are. The evaluation. We are so used in life to calculating how correct something is by using accuracy. Oh, you got 79 out of 100 for your exam, which means you were 79% correct. That doesn't always work with machine learning. We need to choose an appropriate error metric. And so our appropriate error metric, you can click on this link and it will explain a bit more. Our appropriate error metric is the root mean squared error. I'm going to zoom in a bit. Hopefully that helps you see better. Root mean squared error, you can visualize it as your standard deviation curve. So we've got our bell-shaped curve, and we want to try and make this curve as nice and neat as possible, because as soon as we make our curve small, it means all our predictions fit within this small error range. If our curve is nice and fat like that, it means any value goes. We want to try and make our curve as precise as possible. So that's our root mean error squared. That's what that number tells us. What you need to submit, you do not need to submit your code. Your code belongs to you. It is your intellectual property. It's something you need to be proud of. Unless you are in the top 3, then you need to send us your code so we can validate it. What you will submit throughout the competition is you will submit a CSV file or an Excel file that's got 2 columns. The first column is that structure I referred to, which is your persistent ID, so it's persistent ID 54, the second weekday, and the evening rush hour. And then you'll say for that persistent ID on Tuesday in the evening rush hour, cars were going at 10.9 meters per second, because that's what my AI model told me. And so forth. We've gone over the cash prizes. Even if you don't win a cash prize, there are still Zindi points available. So this means make a submission to the competition. You can view what Zindi points are by opening this link over here. And again, only for Angolan participants. We have the timeline here. We've already gone through the timeline, but it's here if you need a reminder. If you get stuck, these are 1-minute videos that show you how to enroll and make your first submission to Zindi, how to create a team. I always recommend working in a team, as you can ask for help and lean on other people and offer help. How to update your profile, so that's how to update your country, update where you're working. Then here are 2 videos on Colab. Colab is a Google product, so how you have Google Docs, Google Sheets, Google Slides. Google has Google Colab. This is an online environment, just how you would use Google Docs online. This allows you to code in Python online. If you would prefer to code in R, please code in R. If you would prefer to use Anaconda or Spider or Jupyter on your local machine, do that. However, I have seen people code in Visual Studio before, so if you're comfortable with Visual Studio, go for that. But if you're new and you have no idea what to do, I recommend Colab. It's my preference. You can see I've got a Colab notebook open in the top over here. Finally, we have the long rules that you can read through. Just the most important is you can team up. Please don't share code outside of your team unless it's on the discussion board. You can make 100 submissions per day. This means you don't have to wait until 6 p.m. tonight. You can code throughout the day and make submissions throughout the day. You can also code throughout the day. Scrolling up to the top, I'm going to click on the data page. You can read more about the data. In 24 minutes, you'll be able to download the data over here. At 10 o'clock, I recommend refreshing your screen and you'll see the data over here. Discussions, this is a great way to ask questions. Kiso and Jewel, I'm not from Angola, I'm from South Africa, but it's great to see people connecting and engaging, and this is a great way to ask and learn bound questions. Over here, this is how you can create a team. You can watch the video on how to create a team. And finally, we have our leaderboard, where you can see everyone's leaderboard over here. I'm going to show you how to open Colab so you can start writing code. So all you do, Google, you type in Google Colab. You click on the Colab notebook. You click Open Colab. We're then going to upload a file. Just waiting for it to register. I'm going to click Browse. I have already downloaded the Angola Starter Notebook. It will become available to you in 20 minutes, so you will see it there. So you're going to open up the notebook, and we're just going to give it a moment to open. Now that it's opened, there's 2 steps you need to do. The first step is you need to click Connect. That's just like connecting to Google's cloud system. Next, you're going to click on this little dot, and there's an upload button. And I've already downloaded the Angola data. Again, you can download it later. And I'm just going to upload this, everything. As soon as all of these files have uploaded and you have a tick over there, it means you're off to the races and you can start. This takes about 3 minutes to upload, so I'm not going to focus on this notebook. I'm actually going to close that and close this because I've already got it open because, oh dear, it disconnected. So you can see it's busy connecting in this top corner over there. Thankfully, my files have saved. I'm going to scroll up to the top. I can close this if I want, but I can also open it again to see all my files. One of my favorite things is this table of contents. So if I want to see the visualizations, all I need to do is and it will pop down there. Or if I want to load the data, I can see it over here. I'm going to scroll up to the top and we're going to go through this step by step. I do not recommend this, but if you have itchy fingers like me and just want to get to the top of the leaderboard as quickly as possible, all you need to do is click Run Time, Run All. And this notebook will just run. And at the end, you'll get a submission file and you can go and submit that onto Zindi. And you don't have to think, you don't have to use your brain at all. And that is not a good thing. Machine learning and data science and AI, it's such a great exercise to engage your brain and to figure out what's going on. So let's go through this notebook together. We're going to install our libraries. So you just, if you want to run a cell one by one, these are called cells. You can just click play. A cell contains lots of lines of code. If I would like to add a new, so you can see it took 6 seconds to run. If I'd like to add a new cell, I can just click plus code over there. If I want to make a comment, I can make a comment, and this means the code won't run. But as soon as I write it like this and it comes out in any other color except green, it will pretend that it's code. So that is code. Over here, I'm importing my libraries. Pandas is a good library to use to read data frames. We've got some geometry libraries because we will be viewing Luanda, so we need to see what it looks like. We've got matplotlib and Seaborn, which are plotting libraries. And over here we have sklearn, which are our machine learning libraries. As you can see, my favorite tool, ChatGPT, is here. It's got all my queries. You can see I use this all the time. So, you don't know what this does? Ask ChatGPT, ask your teammate. What does this line of code do? This line of code imports the random forest class from the ensemble module. Huh? What is that? Ask ChatGPT again. What is a random forest? And it explains even further. So learning data science, learning machine learning has become so much easier with ChatGPT. Ask it the stupid questions. Besides the point, there are no stupid questions. Okay, back here. A random seed, please just keep this line of code in here. You can ask ChatGPT why it's important to have this code, but whatever code you have, make sure you've got it and make sure you've got it at the top. You can change this number to whatever number you want, but just keep it there. Loading the data. So over here we have uploaded our data. So I've uploaded data from my downloads folder. And now I'm reading it in. So I'm reading the train CSV. So here we have train CSV. And what this means is I'm just reading it into Google's memory. I've called train CSV train. I've called test CSV test. Some of you might be new to data science and machine learning, especially supervised learning. Again, big jargon words. Something that's very important in data science and machine learning is a concept of train and test. So train has all this information and it tells you, it's almost like you're practicing for a maths exam and you know what the answers are. So you try out your maths test and then you flip to the back of the book to check if did you get the right answer. Yes, got the right answer. And that's what train is. Then test is your actual test, the actual exam, where you've got a bunch of questions and you just answer them and you hope that they're correct. What's great about Zindi is we won't tell you exactly if you're 100% correct, but we'll tell you, hey, your standard deviation looks a bit like this, or it's starting to become more like this. Yeah, so that's why we have our train and our test. ChatGPT will explain this a lot better than I do. First thing we do is we're going to view our train head. Train head means we're just going to view our top 5 rows of data. Here we have that unique ID I was referring to, our persistent ID, which is the road 17. We've got our weekday, the last weekday, which is Friday, our morning rush hour. Here we have our count norms. Let me scroll somewhere to the middle. Count norm 082. So that's 8:30 to 8:45. There were no cars traveling on that specific road segment. Scrolling to the speed average. So at 5 a.m., 5:15 to 5:30 a.m., cars were traveling an average of 33.3 meters per second. All the way at the end, we've got a column called target. So for the morning rush hour at 6 a.m., the cars were going at an average speed of 26. If we scroll down to test, I'm going to scroll all the way to the end. You'll see that we're missing this target question. This is target column. This is like missing the answers at the back of the book, at the back of your maths textbook. And we at Zindi have those answers on our back end. And you get to submit your test paper to us 100 times today. Over here we have our sample submission. You don't have to show your working out to us. You just have to tell us what the answer is. So for each row in the test, persistent ID 22, other weekday evening rush hour, 22, other weekday evening rush hour, you're going to tell us how fast the cars were going in that section. I don't see any questions coming through, so I'm assuming everyone knows what they're doing and they're feeling confident, which I'm sure isn't the case. If you've got any questions, please do put them in the chat, in the comments on YouTube. This is a data set I haven't mentioned yet, but a data set that's really interesting. It's called graph data frame. If you are a maths major, you might understand the terminology as to why it's called a graph. Even if you're a math major and you don't understand it, doesn't matter. Let's scroll to find persistent ID. Okay, so for persistent ID 63, that length of the road is 194 meters. It's not a toll road. It's not restricted for trucks, so trucks can drive on here. It's not in a residential area. It is paved. Let me scroll over a bit further. Is it in poor condition? No, it's not. That means it's in good condition. And then finally, it has this geometry. If you had to copy paste this into Google Maps, you'll be able to zoom in specifically onto that spot of the road. You don't have to, but it's really fun to do. Scrolling a bit further, I'm going to let you explore this. I'm going to let you explore the train summary or the describe. We've got 32,000 segments, little cuts of road in train. We've got 7 unique weekdays, 2 prediction types. Let's see what our maximum speed target is. Our maximum target during rush hour is 29. Interesting. That means there's some places that cars are going really fast during rush hour. That's definitely the route you want to go home on. Okay, here we have our target distribution. So it looks like most cars during rush hour, about 5,000 cars, travel somewhere around 15 meters per 15 meters per second per road segment. So when you finally get to your test set and you see that all your cars are traveling at 15,000 meters per second, something might be wrong and you might need to go and check your code again. So this is a great way to visualize what's going on. Aguinaldo, I see your question and I will be answering it soon. Thank you so much for your question. Outliers. There are outliers in everything, and as a good data scientist, there are things that you need to understand, just deal with, and one of them is outliers. So over here, we've got a box and whisker plot. We see that there are some targets that are too slow and some items that are too fast. So what can you do with these? I see we have a question called, can we clean? Yes, of course you can clean. You can transform the outliers by a log transformation. Put that into ChatGPT. What does that mean? You can maybe drop the outliers. You can maybe replace them with the mean or median. I'm going to scroll past this visualization. I'll come back to it. Because there's also missing values. And Aguinaldo, I see that you've asked what to do with missing values. Here is a way to visualize them. So ideas that you can do is you can fill them in with the mean or mode. You can fill them in with a very large or a very small number, which is negative 99999. You can drop them. Oopsie. And there's many other ways you can deal with them. So this is a way of cleaning and manipulating the data to make it useful. Peculato, I will show you how to make a submission soon. So thank you so much for your question. Okay, I'm now going to scroll up to my favorite part where we left off, the visualizations. So I mentioned the graph and the geometry. This is why we're using the geometry fields. We're specifically using these latitude and longitude coordinates to map the whole of Luanda. How awesome is that? You can scroll in over here. You can try and find out where is your university, where is your school, is there some average speed information so you can determine the best way to get from part A to part B yourself, which I think is really amazing. Over here, we're looking at just some specific roads and specific road segments. So you can dig down into that as well. So over here, we're looking at the Rua da Samba Road, which looks, it's just this little section over here. It looks like there's a bar and a battery shop. I'm not too sure what that is. We're now going to look at the rush hours and the evening rush hours on Rua de Samba Road. So from midnight, it looks like cars are going really fast, 12.5 meters per second. And it's between 3 a.m. and 4 a.m. Cars are going at 14.5 meters per second. That's crazy fast. So people are definitely speeding along Rua de Samba while it's still dark outside. And now let's look at the average speed in the evening. You can see from 7 o'clock, speeding is at like 13 meters per second. And it slowly gets slower and slower and slower during the course of the day. And it seems like the slowest time is at 3 o'clock on the dot. So personally, I wouldn't leave home at 3 o'clock just because there's too much traffic for my liking. But it's really interesting to see the information. Aguinaldo, thank you for that question. Is the geodata necessarily for inference? Definitely not. You can, let me open up this road visualization. You can actually delete all these cells if you'd like. You do not have to run them. It's not imperative. They could be interesting features if you'd like to dig into them, but you don't have to. Just digging into further, what other things are interesting? We've talked about missing values. We've checked for duplicates. Thankfully, there aren't any duplicates. We can check for correlations. It looks like the average speed at 5 p.m. is highly correlated. So what does that mean? Is that a feature you can add more importance to somehow? Can you maybe drop features of low correlation to make your model faster? What does that look like? Yeah. Here is a plot. We've got some low correlated features. We had some low correlating features. I can't see them now. I'm really impressed that there are people here that just know what they're talking about. They're asking, can we clean? What about missing values? But for those who are new to data science, I want you to look at my scroll bar on the right. I've just spent the last 15 minutes and the last 80% of this notebook exploring the data, visualizing the data, trying to wrap my head around the data. The last 15% of the data, that is the modeling. So data science is not just building a fancy machine learning AI solution. It's about understanding the data. Over here, we have how we train our train. So we're taking that train set that's got the answers at the back of the book. We're splitting that up. So we're going to learn on the top 30%, top 70%, and then we're going to make ourselves a mini test on the bottom 30%. And then we finally check the answers at the back of the book, and we get an RMSE score of 1.77. Over here, we're using the random forest regressor method to predict, to train, and then we're predicting it on just 30% of the test data, and we get a score of 1.77. Interesting. Here we have our feature importance. We keep scrolling through. And peculato, this is where, can you explain how we make a submission? As I mentioned, you do not submit your code to Zindi unless you're on the first, second, and third place, and that is to review to make sure your code does what it says it does. Over here, you've trained your model, you've built a model. You're going to take the test data frame, You're going to apply your CLF model and predict on it. And then you're going to take a submission file. Remember, we viewed our sample submission at the top. We've got ID 22 and other weekday ID and the evening rush hour. So that's assuming that you're going at 8 meters per second. Over here, you have predicted that this car is going at 7 meters per second. I personally would go back and look at that bell curve we made closer to the top to see if these values fit in the bell curve. And that's a good way to plot. If all these values were 15,000, I'd know I've done something very wrong. So yeah, look at the values of your submission file. We then take the submission file, we write it to a CSV file or to an Excel file. Very important, we set our index to false. So Zindi can only take in a 2-column file. We can take in a column called ID, and we take in an index, a column called target. This index over here, the 0, 1, 2, 3, 4, we actually remove that by saying index equals false. I'm going to open up the tab over here. I'm going to click refresh. And here's my baseline submission for Angola. And I'm going to download it. I'm then going to go onto the competition page. I'm going to click refresh. And the competition has just started. So if I go to data, here are all the data files I've been using. Here's the Angola starter notebook. So you can download that and go. But let me make a submission. So I'm going to click submit. I'm going to choose a file. I'm going to go to my downloads and I'm going to get my Angola submission. And I'm going to call this starter notebook submission number 1. And I'm going to click submit. Give it 10 seconds-ish. And I get a score of 1.99. This score of 1.99, I'm going to close that again, is different to this score of 1.77. Yikes. But that's to be expected. The reason we expect it is because this was us just training on our train and testing on our train. And this is us taking our perfected, tweaked model from train and applying it to our test set over here. And that's why we have a different score of 1.99. If I go to the leaderboard, this is why I love doing the demonstrations. I'm at the top of the leaderboard. I'm winning at the moment. So if you run this notebook, you will get the score of 1.99. So everyone can now go and get the data, download it, and off you go. I'm going to sit on this call for a bit longer. If anyone has any questions, please do put them in the chat and I'll answer them. Lorinda, I see you have a question. Hello, how can I help? How can you find this competition? I'm going to put the link over here so you can join the competition. Oh, not that one. This one. Can we use deep learning? Of course you can use deep learning. This notebook is set up to do prediction. But as I mentioned, I'm going to show you over here. There's a strong time element of every 15 increments. So I personally would start thinking about forecasting, We set this up to do prediction, as prediction is one of the easier things to get into. So yeah, but if you want to use deep learning instead of just normal decision trees, go for it. If you want to try a forecasting method, go for it. Feature engineering, as mentioned, 80% of the notebook is looking at the features and the distributions and visualizations. I really encourage you to do feature engineering. Something that could be interesting to look at with feature engineering is maybe pulling in this graph file and using it. You don't have to. There is probably a strong correlation with if it's paved or not, and if it's in poor condition or not, and speed. That's just an assumption, but I think feature engineering could pull that out. You can use correlations with the feature to see which features are important, and is there a way to improve that feature importance? It was a great question. Thank you, Victor, and thank you, Excaitus. I'm going to put myself on mute and I'm going to read the discussion board now. I am here for the rest of the day and will be at my desk if you need me, so please do post on the discussion board. It's right over here. I see we have some discussions already, so I'm going to be answering them now. I see there are no more questions. Good luck, everyone. There's no losing on Zindi, only learning. And I can't wait to see you all on the leaderboard.